I'm Adam Sarafian. I'm a research scientist at Corning Incorporated. My background is in geology. Specifically, my undergrad and master's were in geology from the University of Georgia. Then I did my PhD in cosmochemistry, doing stabilized tope work and trace element geochemistry of planetary basalts, looking at how Earth got its water. I kind of stumbled upon Corning Incorporated right before I graduated and came here straight out of my PhD. And since coming to Corning, I kind of realized there's a big need for people in the geosciences and people with strong work in mineralogy and petrology. Most of my work is in the pharmaceutical glass application space, where I do composition work and look at how glasses behave in melting and forming, specifically vaporization, which can be a big problem. So I didn't realize my work in looking at how planets form, looking at vaporization there, would relate to a technical field in material science. But that's been very, very rewarding. Also been working in other very unique glass spaces, such as high index glasses, where redox can become very interesting. And that was always an interest of mine doing my petrology work. So that's my background and kind of what I'm doing at Corning.
Hi, I'm Bruce Aitken. I'm also an ex-geologist. I did my undergraduate at Amherst College. And then I got my PhD at Stanford, where I did a thesis on experimental petrology, was looking at pressure, fluid, vapor composition, temperature dependence of the phase relations involving carbonate scapolites. And then I did a couple of postdocs after Stanford. I had actually heard about Corning at that time because my office mate at Stanford went directly to Corning on finishing his degree, but he actually had done a thesis in glass, and so it sort of made sense to me. But I couldn't understand why I would have any interest in going to Corning. So I went off on postdocs to the USGS in Reston and to the Max Planck Institute for Chemistry in Mainz in Germany. But I got a job offer from Corning, or an interest in interviewing me, and I came for the interview and found out that they actually have a need for people with backgrounds in where I've had my background, specifically dealing with high temperature phase equilibria, with silicate chemistry, which is a lot of the chemistry in our earth science materials. Most of the minerals we deal with in studying igneous, particularly, and metamorphic rocks are silicates, and that's the type of chemistry that you need to know to work with glass at an industry. And so I came here 38 plus years ago and have been here ever since, because it was it's been fun work, and it's been work that has allowed me to sort of continue my interests in crystallography, in high temperature phase equilibria. And there have been loads of projects along the way. I've got to explore basically the entire periodic table of the elements in making glasses. One of the interesting things about glass is it's sort of an infinite solution, and you can put everything you can think of into it with some limitations. And one of the more interesting materials that perhaps a petrologist or mineralogist would be interested in, that we do a lot of work with, are these materials that we call glass ceramics, of which a typical example is maybe you need to be a little bit dated to recognize the material, but Corningware, which Corning used to make, that we don't make it anymore, but was used for making casserole dishes and various cookware that is a glass ceramic material. And glass ceramic materials are materials that start out their life as glass, and with the ability that we have to form glass into all sorts of weird shapes, including baking dishes or whatever. So Corningware starts out life as a glass object, but is then reheated in order to get it to crystallize, and to crystallize in such a way that it retains its shape during the process. And the science behind this is very much akin to what one would be conversant with in studying fractional crystallization from a magma, or there are other sorts of projects that we are involved with in ceramic materials, where much of the science behind the material is best understood by considering it as an exercise in metamorphic petrology. So one of our main products are the substrates that are used for remediating automobile exhausts. This substrate is made out of cordierite, which is well known to us geologists and mineralogists. But it starts out life in our manufacturing plant as a mixture of clay and talc, and it's reheated to final state as cordierite, and all of the high temperature interactions that occur between room temperature and the top temperature that it receives are perfect examples of a low pressure metamorphic reaction. And so these are just a couple of examples of things that we do at Corning, where probably as a starting out grad student, one has no idea that it's anything like this here at Corning, but and I certainly thought that it was nothing like this. I did not know anything about glass before I came to Corning, but I'm sure glad that I didn't, because there was a lot to learn over the course of 38 plus years.
Yep, and I know a common question that I'm asked, how is it either being relatively new at Corning and also coming from straight from an academia background? The two questions are, what's funding like to actually do interesting science or science that you want to do? And I know for me and talking to Bruce, it seems like there's quite a big investment that Corning makes into allowing us kind of academic freedom. And then also there's encouragement for publishing externally. We do a lot of internal reports and writing kind of patent applications. That's really important, but also it's emphasized to publish externally and do really good science.
Yeah, so in line with that, I mean, it's encouraged that we attend conferences. It's encouraged that we present papers at conferences on our work, and as Adam says, and publish them. Although one of the difficulties that we sometimes run into is that since we're in a business where the goal is to make money for the company, we have certain secrets that ultimately get protected by publishing patents. And prior to patent publication, some of that work is proprietary and cannot be disclosed. But as long as it's been covered by an existing patent, then we are usually free to talk about this. And so in my case, I mean, I've got probably over the years more than 150 publications, in peer-reviewed journals. And so it's not like, you go to industry and that's the end of your quote-unquote academic career. It can continue on long after you've joined Corning. So one of the things that people might not know about Corning is that, we very much value people with backgrounds in such areas as mineral physics, crystallography, experimental petrology, because in the work that we do, one needs to understand, what happens when a molten liquid, is being cooled and being formed into a glass. When you might expect to get crystallization, and what phases might be crystallizing. And another thing that we do in the course of these studies is not just try to develop something for practical purposes, but we have a need to understand these materials from a fundamental standpoint. And so there's a lot of work that goes on to try and understand the structure of the glasses and or glass ceramics that we work with. And as you may know, trying to work with, we're trying to understand the structure of glass is a pretty complicated venture because glass is aperiodic, doesn't diffract like crystals do. But we need to do this in order to be able to relate structure to glass composition to the physical properties of these materials. And so there's a lot of very applied sort of product related work that we do with our materials. But behind that, there's a lot of fundamental work that we do in order to understand things, to better understand them. So when things go wrong in the plant, or when we're trying to scale up something from research to development, on the course of making it into a product, that we're able to solve some of the complicated questions that almost certainly arise along the way. And so this leads to opportunities for publishing a lot of fundamental work, and there's the fundamental work that we do here at Corning is probably on a par with anything that's done academically. So there's no need to feel that one would lose one's academic edge in coming to a industry job, at least at a company like ours.
And also there's a lot of opportunity for international collaborations. We've got labs all around the world with the ones in France and Korea. There's another one in China that we're at the central hub, but there's also specialized resources at those locations. So that's also very rewarding, having international collaborations, both internally and then externally, sometimes going to beam lines or other advanced kind of structural or any other kind of characterization technique is kind of vital to our work.